Welcome to the 3-2 video. Our lesson essential question is, can I prove triangles are congruent or not? So we're going to have some theorems that are going to be used to prove that triangles can be congruent. The first one is if all the sides have a corresponding side that's the same length. So here I have AC, which is the same length as YZ, and I have AB, which is the same length as XY, and I have the same BC as for XZ. So I can say triangle ABC is congruent to triangle, and this is important, the order here matters. Angle A is between 1 and 2 of the similar sides, so that would be Y. And then I went B, and B is between 2 and 3, so that would be the same corresponding side of X. And then Z is between 1 and 3, and Z is between 1 and 3. So if I put down ABC, triangle ABC is congruent to, let's say, XYZ, that is not accurate because A isn't the same angle as X. A same as Y. So the first, second, third need to line up with what's also being the same. Here's another example. They might not all just be this simple. You might need to know that some of the angles or lines are understood to be the same. So line BD is the same for both triangles. So I wouldn't know, it's not going to say BD is the same, like it had all three listed here. You just have to know, well, that's the same line for both triangles, so then it would be, these two triangles would be the same. Another one is side angle side. So here it is, if two sides and the included angle of one triangle are congruent to two corresponding sides and the included angle of the second triangle. And an included angle is the angle formed by two sides of a triangle. So the angle and the two sides would need to look like this. So the angle between the known sides has to be the same as the angle between the other known sides. So here I could say triangle ABC is congruent to triangle. Well, A is going to correspond with X, B is going to correspond with Y, and then Z is the known angle with C, so that would be the last one. I could also mix this up. I could say triangle BCA is congruent to triangle, and then it would be YZX. So as long as the first matches first, second matches second, you can mix them up. Another one is angle side angle. So this is similar to side angle side, but it's an included angle, an included side. And an included side would be the side between the two known angles. So here I have a side, and then the two angles on either side of the side are equal, so I could say these two triangles are congruent. This one is not in the book, but it is useful. So it's called angle side angle. So this one is where I have an angle. I skip side, then I do an angle, and then I have the next side. So I can skip one thing, but I can't skip both things. So I would never say side blank blank going this way, because if I wanted to say side angle angle, I would have side angle side. Oh, I'm missing two, so I can't go this way. I'd have to go this way, which would be side angle angle. So this works, but it's called angle angle side, and you couldn't go this way around. There's another way, it's you should be noting that we're listing 3 sides with the, or 3 parts. You could say side angle, but this doesn't work. And the reason it doesn't work is because I can make 2 different triangles. If I have a known angle and 2 known sides, I could take this side and I could make it go out here, where this is an obtuse angle and this one is acute. So the BC could be here or here. So side-side angle doesn't work. And if you spell it the wrong way, and I won't spell it, but you can figure out that that's not a good word, and we would never want to say that out loud. But side-side angle does sort of work if it's a right triangle. And this one's called hypotenuse leg. So if I have a hypotenuse, and I know it's then a right triangle, and a leg, this is side-side angle. But you would never say side-side angle. You would say HL. So if I have a right triangle and a congruent hypotenuse and a congruent leg, it would work. The reason for this, that it works with hypotenuse leg, is the angle here makes a right triangle. Therefore, I can't have an acute or obtuse angle in the spot here. That right angle would be the one right here. If I make this a right angle, well, then that has to mean that's acute and that can't be obtuse. Another one that doesn't work is angle, angle, angle. If all the angles are the same, I could have it increased by a scale factor. So these 2 triangles are similar, but not congruent. And similar triangles are something we're going to learn about later in the year, but not right now. Once I prove triangles are congruent, I can use a thing called CPCTC, which stands for corresponding parts of congruent triangles are congruent. And what I would use this for is to say that a side or angle that I was not using to prove the triangles are the same, that those all are the same. So an example might be like this, where if I wanted to prove angle A is the same as angle C, well, that would be this angle and this angle. And looking at this, I see it's a right triangle. I have an hypotenuse that's the same, and this side is shared. So these 2 triangles are the same. So I can say triangle ABD is congruent to triangle CBD. And because angle A is lined up with angle C, I can say angle A is the same as angle C because of the reason CPCTC. The corresponding parts of congruent triangles are congruent. And here is a picture of all the different things. I could say 6 different things are the same, 3 sides and 3 angles. And I only need to use 3 things. So if I have side, 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 I could then say all the angles are the same. If I have side, angle, side, then I could say that the other 2 angles and the unknown side are the same. So to review our lesson essential question, can I prove triangles are congruent or not? There are 5 methods that you can: side, 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 angle, side, angle, angle, side, angle, side, angle, and HL. And there are 2 that are no-go, and that would be angle, 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 and then side, side, angle. So to help you get this done for your check-in, there's the 2-3 video that you already did, so good job on that. And then you got Delta Math and 1 Matthew Workspace before your lesson essential check-in.